Have you ever wondered how to solve for x when x is an exponent? For example, when you have 2 to the power x equals 5. You know, if we have the equation 2 plus x is equals to 5, this would be easy because we just subtract 2 from both sides of the equation and we'll get x as 3. But when it comes to this case, we have 2 to the power x equals 5. So how do we solve for x? It's kind of simple solving for x. You just have to do the log of 5 over the log of 2. So that is the value of our x. You can actually check this in your calculator and you get an answer. Now, let's try solving for 2 to the power x equals 5 properly. So we have 2 to the power x equals 5. The first thing we are going to do is to take the log of both sides. So we have log 2x equals log 5. Now the exponent x is going to go to the back of the log. Now it's actually a property of logarithm and it's totally okay to do that. So you have x log 2 is equals to 5. Then to get x by itself, we are going to divide both sides by log 2. So we have x equals to log 5 over log 2. So this is what we did before when we say x is equals to log 5 over log 2. So when you insert this into your calculator, you're going to see an answer. Now, let's try a more complicated example. So this question says log 2x plus 3 is equals to 8. So just as we did before, we're going to take the log of both sides. So we have log 5 to the power 2x plus 3 equals log 8. Now, we're going to divide both sides by log 5. So this will have 2x plus 3 equals to log 8 over log 5. Now, log 8 over log 5 is equals to 1.2903. The next step to get x on its own is subtracting 3 from both sides of the equation. So we have 2x is equals to minus 1.70797. So with this, you can say x is equals to minus 1.0797 divided by 2. And then we have the value of our x to be equals to negative 0.854. Now, let's try another example. There are actually problems that don't need to use logarithm. That is, this problem is like when you can equate the base of the two equations. Now, let's take this example. 27 to the power x plus 1 equals 9 to the power 3 minus x. Now, 27 and 9 can share a common base, which is 3. So, 27 is equals to 3 raised to the power of 3. That means you can multiply 3 times 3 times 3 and to give you 27. And for 9 can also be 3 raised to the power of 2. So, you just have to multiply 3 by 3. So, when we substitute back, now when we write that back into the equation, we have 3 raised to the power of 3 to the power x plus 1 is equals to 3 raised to the power of 2 to the power 3 minus x. Now, when you raise an exponent to another exponent, they can actually multiply. So 3 can multiply x plus 1, and also 2 on the right hand side can multiply 3 minus x. So when we distribute that, our equation is going to look like this. Now, since the bases are identical, you can now set the exponent to be equal to each other. So we have 3x plus 3 is equals to 6 minus 2x. So the next thing is to collect like them. So we add negative 3 to both sides of the equation. Positive 3 becomes negative 3. And then again, we add positive 2x to both sides of the equation. On the left-hand side, sorry, on the right-hand side, negative 2x becomes to positive 2x. You are left with 3x plus 2x is equals to 6 minus 3. So 3x plus 2x is equals to 5x. So we have 5x is equals to 3. Then the value of our x is equals to 3 over 5. So as you can see, there was no need of using logarithm because we can actually make them, because they share a common base, you can just find the base, make the base identical, then we equal the exponent to each other and then solve for x. Now let's take another identical example. So this one says 4 to the power x plus 2 is equals to 8 to the power 3x minus 1. So just as we did before, but this time in this case you can see that their base here, the base they share here is 2. So how many times are you going to multiply 2 to give you 4? There's actually 2 times, that is 2 multiplied by 2. And then for 8, you have to multiply 2 3 times, that is 2 multiplied by 2 multiplied by 2. So then we substitute that back into the equation. And we distribute 2 on the right hand side and 3 on the left hand side. We have 2 to the power 2x plus 4 is equals to 9 to the power 9x minus 3. Now, since the bases are equal, we can actually set the exponents equal to each other. So you have 2x plus 4 is equals to 9x minus 3. So collecting like terms, we're going to add 3 positive 3 to both sides of the equation. On the right hand side, negative 3 will cancel positive 3. And then again, we add negative 2x to both sides of the equation. So on the left hand side, negative 2x will cancel negative 2x. And simply we have 7 is equals to 7x. And then dividing both sides by 7, we have that the value of x is equals to 1. Alright, you can find other examples and practice on solving exponents, but this is where we are going to stop in this video. Until next time, bye.